The operations presented in this video are meant to be instructional to ensure quality construction. This video is not intended to provide a comprehensive overview of safety procedures. All parties should ensure that they are familiar with and follow all safety requirements, policies, and procedures that apply to their specific operation. In this video, we'll be discussing the installation of pipe culverts. The first step to installation is inspecting all of the pipe delivered to the project. Look for cracks, dents, spalls, and any coatings that would compromise the pipe. Review the list of all the lifting equipment provided by the contractor. Make sure to take note of the rated capacities provided by the manufacturer for each size of pipe being installed. Ensure that the contractor performs a visual review of the lifting equipment each day before installation. Be sure to replace any damaged or worn equipment and hardware before use. Prior to excavating the pipe trench, it may be necessary to construct an embankment. The embankment should be 4 feet above the top of the pipe, or to the subgrade elevation of the pipe, whichever elevation is lower. If the pipe is greater than 72 inches in diameter, an embankment is not required. There should be a minimum of 12 inches of cover from the top of the pipe barrel to the bottom of the overlaying pavement's base course. Be sure to note all utilities previously marked before excavating. Look for any evidence of unmarked facilities that may be present at the surface. The trench should be the width of the outside diameter of the pipe barrel plus 4 feet. For pipe trenches deeper than 3.5 feet, remember to lay back the slope appropriately, as shown in RC-30M. Use approved equipment to compact and proof roll the bottom of the trench before placing bedding material. Approved equipment includes self-propelled trench-type rollers, smooth single-drum vibratory rollers with a minimum drum width of 48 inches, hand-operated jumping jack, or hand-operated vibratory plate compactor. Be sure to check Section 108.05c for specific details on approved compaction equipment for trench bottoms. Excavator-mounted hydraulic plate compactors, or HOPACs, are not permitted for proof rolling the bottom of the trench. If the trench bottom is unable to provide adequate bearing for the pipe after proof rolling, the condition must be remediated. Any areas displaying permanent deformation greater than a half inch are considered unstable. Treat unstable areas by excavating material to a depth of 1 foot. Dry the material and recompact it, or replace it with a suitable compacted material. Create an appropriate bedding for the pipe installation. It should be 6 inches deep. For concrete pipe, bedding consists of AASHTO No. 8 aggregate. For metal and thermoplastic pipes, bedding consists of PennDOT No. 2A aggregate material. Do not compact this pipe bedding. Pipe should be placed with bells or grooves upgrade, with the spigot ends fully entered into the hubs. If required, fill the lift holes with a manufactured lift hole plug. The plug needs to be soil tight. Use sustainable string lines, an electric laser beam system, or another approved method to control the pipe alignment and grade. Maintain a minimum pipe slope of 0.35% on all drainage pipes. On straight line pipe placements, join pipe sections according to the joint requirements specified in Section 601.3N. Verify the joint gaps during pipe installation. If joint gaps cannot be maintained within the tolerance listed, stop work and investigate the cause. It is important to take secondary steps to keep pipe joints tight to not allow infiltration of materials through the joints. Excessive gaps at joints can lead to long-term performance problems at these pipes and excessive maintenance costs. For concrete pipe, place a sufficient layer of pipe joint caulking on the inside of the bell end, around the circumference of the pipe. Remove excess caulk on the inside of the pipe following assembly and seal the outside circumference of the joint with the pipe joint caulking material. For elliptical concrete pipe, additionally wrap the joint with 2 layers of geotextile Class 1. Join metal pipes using bands with a minimum width of 12 inches. If the band dimples do not index into each corrugation valley at the pipe end, wrap the joint with 2 layers of geotextile Class 1. For thermoplastic pipe, place preformed pipe joint gaskets in accordance with manufacturer's recommendations. If pipes are protected by end walls or connected to drainage structures, place the exposed pipe end flush within cast-in-place walls or cut off flush with precast structure faces. Finish with mortar. For backfilling along the sides of the pipe, place 2A coarse aggregate in 4-inch compacted lifts using a hand-operated jumping jack or hand-operated vibratory plate compactor. Compact to visual non-movement. Much of the load-bearing strength of the pipe is gained from the support of tightly compacted material at the sides of the pipe. The lateral support becomes especially important and more difficult to achieve when using shoring or a trench box. Thermoplastic and metal pipes are especially dependent on the side support. For pipe installations using shoring or a trench box, follow Section 601.3G of Publication 408. When backfilling at the top of the pipe, do not compact the backfill directly over the crown of the pipe. For metal and thermoplastic pipe, the depth of uncompacted material over the crown should be 1 foot. For concrete pipe, the depth of uncompacted material should be 2 feet. Now we will briefly discuss the materials for use as trench backfill. 2A coarse aggregate is required for construction or replacement of pipe under existing roadways and shoulders. 2A aggregate is also required for new embankments where the top of the pipe is within 4 feet of the subgrade elevation. Compact 2A backfill to visual non-movement as specified. In some instances, the contractor may elect to use material other than 2A coarse aggregate for backfill. However, additional density measurements by nuclear gauge will be required when these materials are used. For areas beyond the roadway and shoulders, or for new embankments in the area above the required 2A, as shown in RC 30, the contractor may use soil or granular materials for backfill. Compact backfill when using soil or Type 1 granular material as specified in Section 203.6b(1), and use a nuclear gauge to measure density. Compact backfill using Type 2 granular materials, such as 2A coarse aggregate, to visual non-movement. Backfill the area above the pipe in 4-inch compacted lifts when using a vibratory plate compactor, pad foot trench roller, or hand-operated impact rammer, also known as a jumping jack. Backfill in compacted 8-inch lifts when using a smooth single-drum vibratory roller with a minimum width of 48 inches. Backfill in a maximum of compacted 12-inch lifts when using an excavator-mounted hydraulic plate compactor. Be sure to use the proper backfill lift height for each specific piece of compaction equipment used. Refer to Section 108.05c for specific details on each type of approved compaction equipment. It is important to ensure that lift height requirements are not exceeded, nor backfill compaction requirements relaxed. Poorly compacted materials placed in pipe trenches often settle after backfill and can lead to depressions or dips in the roadways. Doing a quality job in backfilling and compacting can greatly improve the chances for maintaining a quality, smooth-riding surface of the roadway over the pipe. As work progresses on the pipe excavation, placement, and backfill, document all required information on Form CS6 for each run of pipe. The contractor and inspector are required to sign this form to fully document compliance to the specification for that specific pipe installation. For further reference documents associated with this topic, consult Section 601 of Publication 408, RC 30M of Publication 72, Roadway Construction Standards, and Publication 280, Manufacturing Specifications for Reinforced Concrete Pipe.